Our world is constantly changing. Look around you. You see evidence of transformations everywhere. Leaves change color, water evaporates, and fireworks erupt in brilliant displays. These changes and countless others are driven by chemical reactions. In the fascinating realm of chemistry, substances interact, bonds break and form, and new substances are born. Chemical reactions are the heart and soul of chemistry. They govern everything from the air we breathe to the food we eat. Some reactions release energy, like the combustion of fuel that powers our cars. Others require energy, like the process of photosynthesis that allows plants to convert sunlight into energy. Understanding chemical reactions allows us to make sense of the world around us. It empowers us to develop new technologies, solve environmental challenges, and even understand the complex processes that occur within our own bodies. So, let's dive in and explore the exciting world of redox reactions, a fundamental type of chemical reaction that plays a vital role in our lives. Among the vast array of chemical reactions, a special type stands out: redox reactions. These reactions involve the transfer of electrons, those tiny, negatively charged particles that whiz around the nucleus of an atom. Redox reactions are essential for life and have countless applications in our technological world. Redox reactions are like a captivating dance between two partners, oxidation and reduction. They always occur together like two sides of the same coin. One partner loses electrons, while the other gains them. This intricate exchange of electrons drives a wide range of chemical processes. From the slow rusting of iron to the rapid combustion of fuel, redox reactions are everywhere. They power our batteries, enable us to produce metals from their ores, and even help us breathe. Understanding redox reactions unlocks a deeper understanding of the chemistry that makes our world tick. To grasp the essence of redox reactions, we need to understand the two key players, oxidation and reduction. Think of them as two sides of the same coin, forever linked. Oxidation is a process where a substance loses electrons. It's like giving away a tiny bit of negative charge. When a substance undergoes oxidation, it's said to be oxidized. Reduction, on the other hand, is the opposite of oxidation. It's when a substance gains electrons, like receiving a tiny gift of negative charge. When a substance undergoes reduction, it's said to be reduced. Here's a helpful mnemonic to remember the difference. Oil rig. Oxidation is loss of electrons. Reduction is gain of electrons. Remember this, and you'll be well on your way to mastering redox reactions. In the world of redox reactions, electrons are the stars of the show. These negatively charged particles are incredibly tiny, but they hold immense power. Their movement from one substance to another is what drives redox reactions. Imagine electrons as tiny packages of energy being passed from one molecule to another. This transfer of energy is what makes redox reactions so important in chemistry and in life itself. When a substance loses electrons during oxidation, its overall charge becomes more positive. Conversely, when a substance gains electrons during reduction, its overall charge becomes more negative. This change in charge can dramatically alter the properties of a substance, leading to all sorts of fascinating transformations. Section 5. Rust. A redox reaction in action. Have you ever seen a rusty nail or an old car with a reddish-brown coating? That's rust, and it's a prime example of a redox reaction in action. Rust forms when iron reacts with oxygen and water. During rusting, iron or Fe undergoes oxidation, losing electrons to oxygen or O2. Oxygen, being the electron grabber, undergoes reduction, gaining the electrons that iron loses. This electron transfer transforms iron into iron oxide, Fe2O3, commonly known as rust. Rust is a pervasive example of how redox reactions can impact our everyday lives. It weakens metal structures, requiring costly repairs and replacements. Understanding the redox chemistry behind rust allows us to develop protective coatings and strategies to prevent or slow down this damaging process. Section 6. Cellular respiration, redox reactions fueling life. Redox reactions aren't just happening in rusty nails and car bodies. They're also the driving force behind the very air we breathe and the energy that powers our bodies. Cellular respiration, the process by which our cells convert glucose or sugar into usable energy, is a complex chain of redox reactions. During cellular respiration, glucose is oxidized, losing electrons. Oxygen, the ultimate electron acceptor, swoops in and is reduced, gaining electrons. This electron transfer releases energy, which our cells store in a molecule called ATP, or adenosine triphosphate. ATP is like the energy currency of our cells, powering everything we do, from thinking and moving to maintaining our body temperature. Without redox reactions, our cells wouldn't be able to produce energy, and life as we know it wouldn't exist. Section 7. Redox reactions in our daily lives. Redox reactions are happening all around us, even if we don't always realize it. From the moment we wake up to the time we go to bed, we're constantly encountering these electron transfer processes. When we strike a match, we're initiating a combustion reaction, a classic example of a redox reaction. The heat from the matchstick provides the activation energy needed for the fuel in the match head to react with oxygen in the air. This rapid oxidation releases heat and light, allowing us to start a fire. Another everyday example is the browning of fruits and vegetables. When we cut an apple or potato, enzymes inside the fruit or vegetable react with oxygen in the air, causing oxidation and the formation of brown pigments. This browning process is a redox reaction that can affect the taste and appearance of our food. Section 8. The power of redox, from batteries to bleaches. The power of redox reactions extends far beyond our everyday lives. Scientists and engineers have harnessed the principles of oxidation and reduction to develop a wide range of technologies that shape our world. Batteries, for instance, rely on redox reactions to store and release energy. A typical battery consists of two electrodes made of different materials immersed in an electrolyte solution. When the battery is connected to a circuit, a redox reaction occurs, causing electrons to flow from one electrode to the other, generating an electrical current. Bleach, another common household product, also relies on redox reactions to whiten clothes and disinfect surfaces. Bleach contains oxidizing agents that react with stains and bacteria, breaking them down into colorless or less noticeable substances. Section 9. Redox reactions, shaping the future. Redox reactions have played a pivotal role in shaping our world, and they continue to hold immense promise for the future. Scientists are exploring new ways to harness the power of redox chemistry to address some of the world's most pressing challenges. In the field of renewable energy, researchers are developing new types of batteries and fuel cells that rely on redox reactions to store and release energy from renewable sources like solar and wind power. These technologies could help reduce our reliance on fossil fuels and mitigate the impacts of climate change. Redox reactions are also being explored for their potential in environmental remediation. Scientists are developing innovative techniques that use redox reactions to break down pollutants in water and soil, offering promising solutions for cleaning up our environment.